Hello everyone, welcome to today's class. This is Teacher Simon taking you through Cambridge International AS and A-Level Mathematics Paper 5-2 for May, June 2024 for questions 1 to 4. Question 1. Rajesh applies once every year for a ticket to a music festival. The probability that he is successful in any particular year is 0.3, independently of other years. That means this one can be either a binomial or a geometric distribution. Part A. Find the probability that Rajesh is successful for the first time on his 7th attempt. Now, we don't know here the number of times the experiment is done, but they are just telling us that he's successful on that 7th time. So our P here is 0.3, and then our Q here is 0.7. So this is a geometric distribution. Why is it a geometric distribution? N isn't fixed or known. The number of times the experiment is done, okay, isn't fixed. Now, probability of X is equal to 7. If this person is successful on the 7th time, that means has been failing for the last 6 times. So Q power 6, then P power 1. Q power 6, Q is 0.7, then to the power of 6, then times P, which is 0.3. So putting this in the calculator, what do we get? 0.7 power 6, then times 0.3. So it gives us all of those figures, but to 3 significant figures, I'm going to write 0.0353. 0.0353 to 3 significant figures. Next part B. Find the probability that Rajesh is successful for the first time before his 6th attempt. Okay, now I can draw what we call a tree diagram. This is for the geometric. So you can succeed on the first. Then when you fail on the first, you continue. You can succeed on the second. If you fail, then you continue. This is the third one. When you fail, then you continue. This is the fourth one. When you fail, how many do we have? So before the 6th, that is less than 6. So we have 1, 2, 3, 4, 5. This has to be the last one. Okay. So we have P, Q. Now, for less than 6, if this person succeeds on the those times before the 6th attempt, that means can succeed on the first one, on the second one, on the third one, on the fourth one, on the 5th one, all of those. Okay, but do you realize that there is one scenario that we have left out? It is this one, when all of them have failed. So that means probability of X less than 6 is going to be equal to 1 minus Q power 5. Okay, this one here. Instead of disturbing myself getting P plus QP plus Q squared P, then plus Q cubed P, then Q power 4 of P, I just get 1 because total probability is 1. Then I subtract this one that is left out. So we shall have here 1 minus 0.7, then to the power of 5. So what do we get when we put in the calculator? 1 minus 0.7 power 5. And then that is 0.83193, but to 3 significant figures, I can write 0.832. 0.832 to 3 significant figures. Part C. Find the probability that Rajesh is successful for the second time on his 10th attempt. The second time on his 10th attempt. So I have an outline here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So is successful here on the 10th time. That means here is successful 1 time. Okay, the rest are failures. So can be successful here on the first time, then on the second time, maybe on the third time, like that. So I'm going to treat this one as a binomial. Okay, there is one success in the 9. So that means my probability here is going to be, out of the 9 there is one success, so 9 combination 1, and the probability of getting a success is 0.3, then power 1, then times the probability of the failure is 0.7, then power 8. Then after that, I'll multiply with the probability of getting a success here on the 10th time, which is 0.3. Of course, this 9 combination 1 is a 9. Then we shall have 0.3 squared, this and this, okay? They'll give us 0.3 squared. Then times 0.7 power 8. So what do we get altogether? 9 times 0.3 squared times 0.7 power 8. So to 3 significant figures, there we shall write 0.0467. 0.0467 to 3 significant figures. Next, question 2. Sava has a coin which is biased so that when it is thrown, the probability of obtaining a head is a third. He also has a bag containing 4 red marbles and 5 blue marbles. Sava throws the coin. If he obtains a head, he selects 1 marble from the bag at random. If he obtains a tail, he selects 2 marbles from the bag at random and without replacement. Find the probability that Sava selects at least 1 red marble. At least means greater than or equal. Okay, so I'm going to simplify this using the tree diagram. So Sava throws a coin, and of course we have 2 outcomes, a head and a tail. The probability of getting a head is a third, and then this one will be 2/3. Okay, then when he obtains a head, he selects 1 marble from the bag. So 1 marble from the bag, and remember, you can either get red or blue. How many red marbles do we have? There are 4. Then the total will be 4 plus the 5. So we shall have here 4 over 9. And then for blue will be 5 over 9. Okay, and then they said that if he obtains a tail, he selects 2 marbles from the bag without replacement. Remember, picking without replacement, the total is reduced by 1 every time you pick. So we can get red and blue. Of course, the probability of picking a red is 4 over 9, and then here it is 5 over 9. So this person picks 2 balls at random without replacement. So another picking can be a red or a blue. Again, you can pick and it is a red or a blue. Okay, so since you have already picked a blue, the probability of picking again another blue is going to be now 4 because 1 is already out. So you will get 4, and then the total will be 8. It has reduced by 1. So 1 minus 4 over 8 is the same as 4 over 8 here. Okay, then you have already picked a red. So what is the probability of picking a red there? Remember, they have reduced by 1, so that means you will remain with 3. So I remain with 3, then here over 8. That means this one will be 5 over 8, just like that. Now, when we say probability of at least 1 red, that means we can get 1 red, 2 reds, like that. But I can say 1 minus picking no red. Okay, picking no red. So when I'm picking no red, then it can be here, head, and then you pick a blue. Then we can have tail, then blue, and then blue. You see, those are the ones that we are going to have. So the first one is the head, a third, and then you pick blue, so 5 over 9. Then we can add 2 over 3, that is picking the tail. Okay, then you can pick a blue and then a blue. So 5 over 9, then times 4 over 8. Just like that. So when we put all of this in the calculator, what do we get? 1 minus, here I'll have 5 out of 3 times 9, that is 27. And then plus 2 times 5, 10, times 4, 40. Then we shall divide by 3 times 9 times 8. So this one will give us altogether 17 out of 27. 17 out of 27. Then next, part B, find a probability that Sava obtains a head given that he selects no red marbles. Okay, he obtains a head given that is conditional probability, he selects no red marbles. So we can put red complement. So this one is going to be probability of H, then intersection R complement out of probability of no red. Okay, when we go up here, head and no red, that means we are getting red and then blue. Okay, so the head is here and then the blue. You see that? So that is what we have up. 1 over 3 times 5 over 9. 1 over 3 times 5 over 9. Then down here, no red. Now, we subtracted something here, 1 minus no red, and then we got this one. That means to get probability of no red, I will say 1 minus this one. As simple as that. Okay? It can be 1 minus, that's 17 over 27. So 27 minus 17, don't you get 10? Yes, that is 10. So 5 over 27, then we are dividing by 10 over 27. Okay? And then, of course, using the rules of fractions, this can be 5 over 27, then times the reciprocal of the denominator. This one will go, and then 5 goes into here 2 times. That means we are going to get our answer as a half. Question 3. The weights of oranges can be modeled by a normal distribution with mean 131 grams and standard deviation 54 grams. Oranges are classified as small, medium, or large. A large orange weighs at least 184 grams and 20% of the oranges are classified as small. Find the percentage of oranges that are classified as large. Now, we need to first find the probability, then after we multiply it by 100. So probability of x greater than 184, okay? Because they said that a large orange weighs at least, so at least means greater than or equal. But in normal distribution, greater than or equal and greater than, we take them as the same, okay? Then, and 20%, those two are actually different when it comes to binomial approximation to normal, okay? Now, a large orange weighs at least 184 grams, at least. So we are using this one greater than. Then we standardize this one. So probability of z, then greater than. Remember, z is equal to x minus mu out of the standard deviation. So this is 184 minus mean is given as 131 out of the standard deviation 54. Okay, then when we get 184 minus 131, this one gives us 53, then out of 54. Okay, here I can use my calculator right away. So this is how you do it. So I'll go to my calculator here, then I press mode. I go to 3 where there is statistics, and then this one will come on the screen. Then I'll just press this button here, SC. Okay, then start comes on top of my screen. Then from there I can press shift, then start, which is 1. So you press button 1, and then you can see what has come on the screen. So you press 5, that is option 5, it is for normal distribution. So 5, and then 1 is for less than, the P is for less than, and then R is the one which is for greater than. So I'll press 3, then R will come on top. Then I'll just say 53. I will just put this number 53 out of 54, close the brackets. I'll get that answer, 0.53. 16318. 0.16318. The calculator gives up to 5 decimal places. So the percentage is going to be, we just get this value here, and then we multiply it by 100. So times 100. So this one is going to be 16.3%. That is to 3 significant figures. I can get 16.3. Part B, find the greatest possible weight of a small orange. Greatest possible weight of the small orange. Now, we are given here that 20%, there's something they said about 20%. 20% of the oranges are classified as small. That means you have a range from this to this. It is 20%. Okay? These are small. Then from this one to another one, this one is going to be medium. Then from here to here, that will be large. You see that? So, we need to get this largest value here, the upper limit of the small ones. Okay? I'm going to say that probability, I need to find that value for the greatest. So x less than, let's say, w, then is supposed to be equal to 0.2. And then from here, we standardize probability of z less than z1, then is going to be equal to this 0.2. We need to look for the z value that corresponds to this 0.2. But in the table, we are given values that are greater than 0.5. Now, we need to find out whether z is positive or negative. So what you need to do when you reach there, always do sketching, okay? Do two sketches. And then you put your z value, one on the right, then one on the left, okay? Of this standardized mean, the 0. So this one is a negative. Now, they are talking about less than. So look at the less than part of the whole of this, and also this one here. So which of these two do you think corresponds to the 0.2? It has to be this one here, okay? 0.2, rather than this one here, because already this part here is 0.5. So that means there is something that you are adding on here. The answer here is going to be greater than the 0.5. So you cannot say that that is 0.2. So z, therefore, is not going to be a positive. It is going to be a negative. Then I will say minus z1 is going to be equal to the phi inverse of this 0.2. But since we don't have values in the normal distribution table for those values that are less than 0.5, then what we do, we just subtract this from 1, and we instead get the one for the bigger value because that is the one that we can locate, okay? So we can say 1 minus 0.2, and then our negative z1 is going to be the phi inverse of the 0.8, okay? So let's go to our table, and then we find out what we get from there. So this is our normal distribution here, and you can see that this one represents, look at this bell-shaped curve, for probability of z less than, okay? Which is here defined for less than z. Now we are looking for 0.8. Before you even look for them, always check down here for these confidence intervals given here. So this is for 75, 90%, 95%, 97.5%. So we don't have 80. Okay. Now let us look for that 0.8 from there, from this table here. Now if you can check 0.8, this is 0.7995. Then 0.8 has to be in between here because this one is already bigger. So we pick this value here, we pick what is here. So I'm going to have here 0.84, okay? 0.84. Now, what do we add on this 0.7995 to get 0.8? So it says 0.8000 minus 0.7995. Of course, this one will give us a 5. So the rest are zeros here. Then you go this other side and you look out for the 5. So you can see it is here. Okay, this one we have gotten here. So it is here. Then you go up and read off that value. That 2 you get is the third decimal place for that Z value. Okay, so then we can go back and write 0.842. So negative Z1 is equal to 0.842. So meaning that our Z1 is equal to negative 0.842. Remember, Z is equal to X minus mu out of a standard deviation. So we shall have this negative 0.842 then is equal to the X value is that W we are looking for minus the mean. Mean was given as 131. Standard deviation was given as 54. Then we make W the subject of the formula. So 54 then times negative 0.842 then is equal to W minus 131. So meaning W is going to be equal to, when this one crosses, it becomes a plus. Okay, so we shall have 131 then minus 54 multiplied by 0.842. So I've just put this negative just here. Okay, then what do we get as our W here? 131 minus 54 into 0.842. It gives us 85.532, which I can write as 85.5. 85.5. Okay, maybe grams to 3 significant figures. So that is that. Question 4. The back-to-back stem and leaf diagram shows the annual salaries of 19 employees at each of 2 companies, Petro and Ravon. It is given here. Remember, for the stem and leaf diagram, these numbers in the stem must be increasing downwards, and then the numbers on the leaves must be increasing to the right. Okay, if it's on the right, so they must be increasing from the stem, okay, and then outwards. So they increase this way and then this way, and then they must align vertically. You see, all of them are aligning vertically. So don't write numbers in space, just in case you are told to draw the stem and leaf diagram. Okay, now there is the key here. They are telling us that 2/31/5 means 3-1, that is the one in the middle, then jump this way, that is a 2, but then they are adding on 2 zeros. Okay, so it means $31,200. Okay, and then also this other side, it will be 315, then you add the 2 zeros. Okay, so a key is very important when it comes to the stem and leaf diagram, because in here we don't write decimal points. You can be given numbers in decimals, but in here we don't write them, but we state them in the stem. And then thousands, those big numbers, like here it is multiplied by 100, so the zeros, the 100 that they multiply on each of them is just stated in the key. So it's very important to understand the key. And even when you are drawing your stem and leaf diagram, if you are told to do so, you have to show the key. Okay, so find the median and the interquartile range. So since these numbers here given are odd, that means I'm going to cross from the extremes. I will remain with one figure in the middle. So let's say we had 9 numbers, okay? A, B, C, D, E, F, G, H, okay? 1, 2, 3, 4, 5, 6, 7, 8, E, H, I. We are going to cross from here like that until we remain with one figure in the middle. But this one figure is which one? There are 9 numbers, but this figure here is the 5th number. Okay, 5th. But 5th is the same as saying 9 plus 1, then divide by 2. You see that? So that means if the number of digits or the number of data points given is odd, then we shall first add a 1 and then we divide it by 2. So median is therefore going to be the 19 plus 1 over 2, that value. Automatically, this one will be the 10th value. Okay, the 10th value. So we can count, it is for petrol. So this will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it is here. I'll write 320, 320. Okay, but then looking at the key, after reading that number, then I add 2 zeros. You see that? So I'll add on the 2 zeros here. That will be the median. And then next we are supposed to find the interquartile range. So we need to find Q3. It is also going to be the same. 3/4 of the 19 plus 1. Quarter is that number that divides the given distribution into 4 equal parts. Okay. So what do we get here? 20 divided by 4, that is 5 times 3, you get 15. So the 15th value. Okay. So what is the 15th value? We can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it is 3, 3, 5. Okay. I'll write 3, 3, 5. Then remember to add on the 2 zeros. Okay. That is for Q3. Then we need to get the lower quartile, Q1. Q1 is going to be a quarter of, again, 19 plus 1. That value, which is going to be the 5th value. Okay. And what is the 5th value here? This is 1, 2, 3, 4, 5. So it is 3, 1, 2. Okay. I'll write 3, 1, 2. Then I add on the 2 zeros. So meaning that now our interquartile range is going to be interquartile range is going to be equal to the Q3 minus the Q1. So Q3 is 33500 minus 31200. Then when we subtract these ones, we get $2,300. So that is that. Next, the median salary of the Ravon employees is 33,800. The lower quartile is 32,000, and the upper quartile is 34,400. Part B, represent the data shown in the back-to-back stem and leaf diagram by a pair of box and whisker plots in a single diagram. We are going to put a scale. So that scale you put must be uniform, okay? And when we go back to the results given here, the minimum, this is in 30,000. You see that? 30. So that means I can begin from 30, and then the maximum is 369, then with the 2 zeros. So that means I'm going to start with 30. I'm going to have 30,000, okay? So I can get my ruler, and then I draw a scale. I first draw a line here for this axis, and then I can put here 30,000, okay? Then we can go to 31, because I'm going up to 36 or 37. The biggest is 369, okay? Then 00. So we are going to have 31,000. Then we can have 32,000, 33,000, 34,000, 35,000, 36,000. Okay, and then this one will be like 37,000. Now let's begin with petrol. So for petrol here, the list is 300. Then we add on the 2 zeros. Okay, so 300, and then we add on the 2 zeros. That is 3,000. Okay, so I can now put Let me count 1, 2, 3, 4, 5. So I can put here. And then the lower quartile of petrol. Already we have calculated it here. It is 31200. Okay, so we come back this side and we look for 312. So 31, then 2, we add on the 2 boxes here. So then I'll draw a line here, just like that. Then the median for petrol, because median is the line that is within the box, okay, for the box and whisker. Median, we have gotten it as 32000. So 32, when we come back here, it's already on this line. So 32 here. Then next, it is going to be the upper quartile. So the upper quartile for petrol, it is 33500. Okay, so we come back here, 33500 with 33 here, then 500 is in the middle. So it will be here, 33500. Okay, and then the largest value for petrol is going to be for petrol is on the left, so it is 3. It is here 368, then 00. So we come back here and we put 368. So it has to be this other side. We just leave 2 boxes from the 700, the 7000. So it will be there. Then we can connect this one, just a box there. And then I can connect this one like this here, and then this one like that there. Okay, then you label it, don't just leave it there. This is for petrol. Then next we go to Ravon. So Ravon, first of all, they have told us that the median is 33800. So 33, then 800. I'm going to skip one box such that I make it a little bit spacious and looking nice. So 33800 will be here. Okay, then we shall have the lower quartile is 32,000. So the lower quartile is here. And then we are given the upper quartile is 34,400. 34, then 400. So I will skip 4 here. So that is it. And then now what is the highest and then the lowest? So the highest for Ravon is 369, then 100. So that means I will come back here and I look for 369. 369, you can see that it is here. We just leave one box, just like that. And then the least one is, remember, box and whisker plot has only 5 values: the lowest, the lower quartile, the median, the upper quartile, and then the highest value. So the smallest is 30200. 30200. So I'll come back here and I put 30200, which is actually here, 30200. So 30 is here. That means 200. I'm going to skip 2 boxes. So that is that there. And then I can connect the boxes here. Where the box starts from is the lower quartile. Where it ends is the upper quartile. The line within the box is the median. Okay. Then I can connect this one to this, and then this one to that one there. And then I label this one as Ravon. You see? So that is what we have there. The next part, C, comment on whether the mean or the median would be a better representation of data for the employees at petrol. We have what we call measures of central tendency. We have mode, median, and mean. Okay, when you look at mode, is the most appearing number. Median, that is the value that is going to remain in the middle. So you are crossing from the extremes. Okay, that means if you have an extreme value, it is going to be cancelled out. You see that? But then mean, you are going to add all of those numbers, you divide by how many they are. That means if you have an extreme value, it is going to affect your mean. It is going to raise it. You see that? So when we go to petrol, let's check petrol again. Petrol. Do you see that here there is 3,4 and then here, but in 3,5 there is nothing, but we have 3,6, then 80. So this is an extreme value. So when I use mean, it is going to raise it. It is going to give an elevated value. So because of this extreme value, then we can use median, because for it is going to cancel it out when you cancel from the extremes to find the median, you see? So I would therefore say that median would be a better representation of data due to the existence of an extreme value. Which value is that? 3,6,800. Okay, as simple as that. So that has been it for this paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next videos.